Welcome. Today we're going to be talking about how to solve equations that involve absolute value. Absolute value equations contain at least one absolute value expression. Simplest form of the absolute value expression. Um, it's a little weird that absolute value is not a vocab word, but okay. Absolute value. The simplest form of the absolute value equation is absolute x equals n. Since absolute value represents distance, you must consider the case where the solution is x units from 0 in the negative direction and the case where the solution is x units from 0 in the positive direction. So what this means is every problem is going to be broken into two problems, one with where we are going to get a positive value and one with a negative value. So when we solve equations involve absolute value, there are two cases. Case 1, the expression inside the absolute value symbol is positive or 0. Case 2, the expression inside the absolute value symbol is negative. So for any real numbers a and b, if the absolute value of a is equal to b and b is greater than or equal to 0, then case 1 and 2. Case 1, positive a equals b. Case 2, a equals negative b. So what they have is the absolute value of d is equal to 3. So there's a negative 3 and a positive 3 it could be. Consider the equation x equals 3. This means that the 2 points on the number line where the distance between 0 and x is 3 are solutions to this equation. The distance between 0 and negative 3 is 3. So what they're saying here is right here represents the positive case, and right here represents the negative case. For each absolute value equation, you must consider both cases. To solve an absolute value equation, first isolate the absolute value on one side of the equation if it's not already by itself. Before we do that, Clark says that the solution set for absolute x equals 8 is 8. Is he correct? Well, if we take a look right here for our example, it says absolute d is 3, so d is equal to positive 3 or negative 3. We don't have the or over here, so partially. They're partially correct. The complete solution set would be x equals 8 or x equals negative 8. Example 1. Solve the absolute value of y plus 2 equals 4. Then graph the solution set. If y is non-negative, then the absolute value of y is y. So here we have our case 1, where we're going to keep the equation positive. So case 1 has equation 1, where it is the absolute value is removed and everything is positive. Case 2, we remove the absolute value sign, but we let what it equals be a negative. So we have y plus 2 equals negative 4. Now that we have two equations, we're going to solve them. So for this one, they have a subtract 2 from both sides. If we subtract 2, like terms combine and cancel out. 4 minus 2 is 2. So on the number line, we have an answer at 2. Then over here, y plus 2 is negative 4. Same thing, we're going to subtract 2 from both sides. Like terms combine. They cancel. Our like terms combine. -4 plus -2 gives us -6. So the solution set is 6, -2. Notice that we're not using parentheses, we are using brackets. The brackets indicate that this is a set of numbers. Let's check. We substituted -6 and 2 into the original expression, so we take -6, plug it in, -6 plus 2 gives us -4. The absolute of -4 is a +4. Trying it with 2. 2 plus 2 equals +4. Absolute +4 is 4. Correct. Check. Graph the solution set for 2t minus 4 equals 8. All right, so the first thing you need to do is check to see if the absolute value is by itself. It is. So now that the absolute value is by itself, we have to write the two cases. One where we leave what it equals the same, and one where we make it negative. Now we have to solve the equations. The first step will be the same. These are 2 steps, just like we do on our drills. So first thing we have to do is move our constants over. So I have a -4 right here. We get rid of it by adding 4. Whatever we do to the left, we do to the right. Over here, I want to get rid of that -4, so we're going to add a 4 over here, which lets us add a 4 over here. Cancel, cancel. We get 2t equals 12, and we get 2t equals -4. From here, same step for both of them. We're going to do the opposite of multiply by 2. We're going to divide by 2. And that gives us t equals +6 and t equals -2. So our solution set is -2 and +6. Keep in mind the values that you will need for graphing. If the values are very large, use a number line and scale that are reasonable for the situation. Example 2, solve an absolute value when n is less than 0. We have the absolute value of 3x minus 4 equals -1. Means the distance between 3x and 4 is -1. Since distance cannot be negative, the solution is well, there is no solution. Absolute value cannot be equal to a negative number. There's no way to do it, so there's just no solution. So, if you are dealing with an absolute value, they're going to say it's the empty set, no solution. Oh, that's funny. So this is the symbol for empty set. There is no solution. The empty set, all that means is it is a set that has no answers. There's nothing in it. That's what it means, the empty set. I'm fine with no solution though. Which statement must be true for the solution set of a times x plus b equals c to be no solution? So, if a is negative, the solution will be no solution. Absolutely not. A can be negative. That won't work. If b is negative, that's not going to change anything. If c is negative, absolutely. If c is negative, an absolute value cannot equal a negative number. If c is positive, absolutely not. If c is positive, it's just a regular problem. Example 3. Depending on the size of each song, Luna's phone holds an average of 2,000 songs, give or take 250 songs. Write and solve an equation involving absolute value to find the maximum minimum number of songs that Luna's phone can hold. The maximum minimum numbers of songs will differ from the average blank by song. So if it's give or take 250, complete the table to write an equation that represents the maximum and minimum number of songs. The difference between the number of songs the difference between the number of songs I'm not quite sure what their words are going here, but the equation we should be coming up with is the absolute value of x minus 2,000 needs to equal 250. So, from there, the difference between the number of songs and blank is 250. So from here, we have our case 1 and case 2. Case 1, keep it positive. And case 2, swap it to be negative. Both cases have the same step. We're going to add 2,000 to both sides. That gives us 2,250 or 1,750. So our solution set is 250 to 1,750. The maximum minimum number of songs are 2,250 and 1,750 respectively. Does the solution set mean that Luna's phone can hold only 1,750 or 2,250 songs? If not, how many songs can it hold? Anywhere in between. So we could do this as an inequality. The phone holds 1750 less than or equal to x less than or equal to 2250. So the phone can hold anywhere in between those two. Honestly, it could hold 0 to this. But they're going with average phone capacity. All right, skydiving. It takes approximately 6 minutes for a skydiver to land after she jumps out of a plane, give or take 30 seconds. What is the range of time in seconds it could take a skydiver to land? All right, so this is going to be 6 plus or minus 30 seconds. So what they did over here was x minus 6 equals 30. And this becomes our two equations. X minus 6 equals 30. X minus 6 equals negative 30. Adding 6 to both sides, we get x equals 36. So adding 6 to both sides, we get x equals negative 24. Oh no, we're at, yeah. So our solution set fits solution in seconds. All right. So 6 minutes is 360 seconds. So it could, oh no, we set that up wrong. So because it said it wants this in seconds, we need to translate this to seconds first. So our equation should be the absolute value of x minus 360 equals 30. There we go. Now this will work better. So equation 1 is x minus 360 equals 30. And then equation 2 will be x minus 360 equals negative 30. Add 360 to both sides, we get x equals 390, and x equals positive 330. So it could take anywhere from 330 seconds to 390 seconds. Moving along. Example 4, write an equation involving absolute value for the graph. All right, our points are 17 and 27. Find the point that is the same distance from 17 and 27. So we're looking for equidistant. They count 1, 1, 1, 2, 2, 3, 3, 4, 4, 5 at 22. So if 22 is the center, so the equation x minus 22 equals 5 gives us this situation. Label each graph with the correct equation. All right. So what this is pointing out is when we have a setup like this, this is the distance. To the midpoint. So let's see. Since that one's 6, that means there's going to be 12 units apart. It should be the biggest one. Let's do it in color to make this easy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So for this one, the overlap is at negative 3. And that's going to be x plus 3 equals 6. next up, let's do the smallest one. Our smallest one should go to the ones that are smallest apart. So 1, 2, 3. 1, 2, 3. It's at 1. So this is x minus 1 equals 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is 10 units. Oh, there's two of them with 6. Let's take a look. If I plug in -9, -9 plus 3 is -6, correct? If I plug in +3, 3 plus 3 is 6. Yeah, got that one right. All right, so then this one will be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is at 3. X minus 3 equals 5. And we can test it. Plug in a -2. -2 minus 3 is 5. Spits out -5, spits out +5. Plug in 8. 8 minus 3 is +5. All right, so that means our last one is going to be x minus 1 equals 6. Write a general rule that can be used for exercises similar to example 4. All right. X minus A equals B. Midpoint. What we saw when it was -22, the midpoint was +22. When it's a -1, the midpoint was +1. -3, midpoint was +3. When it was a +3, the midpoint was -3. So we want to make sure there's a minus there, and the midpoint will be A. Point 1 will always be A plus B. And point 2, A minus B. And that's it. Thank you so much.